Hello everyone, let's start solving today's Leetcode daily challenge question. So the question is design a number container system. Design a number container system that can do the following. Okay, so insert or replace a number at a given index in the system. Return the smallest index for a given number in the system. Okay, so we have to implement these three methods. The first method is number containers, which initializes the number container system, and the second method is void change, which accepts two inputs as index and numbers and fills the container at index with the number. And if there is already a number at that index, replace it. Okay. And the third method we have to implement is int find, which accepts a number and we have to returns a smallest index for a given number, or minus 1 if there is no index that is filled by number in the system. Okay, so if we see this example, this number containers, this input is basically this is calling this method. Okay, this is just an instructor, sorry, constructor. Okay, so this will initialize our system. So find, if find is given, here you can see 10. We have to find the 10 in our number system. Initially it is our number system is empty, so it is returning minus 1. And here it is given change and 2 comma 7. So 2 is the index and 10 is the number. So at index 2 we will place 10 number. Now again change, at index 1 we will again add 10. At index 3 we will add 10. At index 5 we will add 10. So 10 is at which indices 1, 2, 3 and 5. And again if we are getting find 10, what we have to return is we have to return the smallest index for a given number. So which is the smallest is 1. So it is returning 1. And then again change request is there, so 1 comma 20. So we have to replace 20 at index 1. It was 10, right? So we will replace 20 at index 1. So okay, so next is find 10. So 10 will be at now second position at index 2. Why? Because at 1 we have 20, now we replaced it. Now at that index 20, 10 is not there, so we got 2. Okay, so yeah, this is the only one example here it is given. So what we have to do is first, let's see, we as we have to return the smallest indexes, that means we have to store somewhere index 1, index 2, index 3 for that number 1. Okay, and also what we have to do, we have to return, we have to change for that index which number is there. So we can write index 1 is equal to number 1. Okay, that means for that index only one number should be there, not two. Here you can see initially at index 1 10 was there. When the request for change came for at index 20 number, then we replaced it. So for each index there will be one number. So we need these two. So what we will do, when we get find, then what we will do for that number which is the smallest, that means which is the first element, we will use a sorted set here, so that we'll get the first number we have to return, right? So we can return this directly. And if we get the change this index with this number, then what we can do is first we will check if that number is there. If it is there, if it is not there, then we will initialize with that sorted set. Okay, and next thing what we will do, we will we will check here for that index if there is a previous value, and if the previous value is same as what we are passing. So let's say we get again the same request as 3 comma 10. So again we don't need to replace it because it is the same, so we will not do anything. If it is not same, we will get a previous value, like for example this 110 and 120, we'll get this previous value, and we will remove the index from this previous value. Like here 10 is equal to, there will be 1 2 3 5, right? So we'll remove 1 from here. And next what we will do, we will add for that number, for 20 number, for 20 equal to, we will add that index. And what we will do, we will also change this for that index. For index 1, the value will be 20. So let's say I'll just try run. What I'm trying to say is, let's say our number initially it is empty and it is asked 10, so it is returning minus 1. Now 2 and 10. So what we will do, for 10, is there any map? No. So we will initialize it and at index 2. And for index 2, what is the number? 10. Now next request is 1 and 10. For 10, again it will be 1 comma 2, 1 and 10. And for 2 it is 10, again for 1 it will be 10. Okay, now next request is 3 10. So for 10 we have, it is at 1 2 3, and 2 is 10, 1 is 10, and again 3 is 10. So similarly for 5 also, I will add here 5, and 5 is 10. That means at index 5 the number is 10. Now the if there is a request as find a 10, so which is the least index? 1, we will return 1. Now 1 and 20, this new request came as 120. So what I will check for, is there any number with 20? No, only 10 is there. So what we will write, we will initialize 20. Okay, we have 10, again we have 10 like this, 1 2 3 5, right? Initially we will initialize it with what? 20 empty. And we will check if for this index, for index 1 here, if the number is 20, no, then what is the previous value? 10. So we will remove this index 1 from this 10. That means I will remove this one from this 10. And what I will do, I will assign 20 to 1, and I will add here as 1. Okay, so this is my again new thing. Here I will get for index 2 10 value, for index 1 20, 3 10 5 10. So what will be the value? Find a 10. What is the minimum index? Is 2. So we are getting like this. So let's start coding. For that, to store this, we will take one as, this is key and value. This is key and value. So one map which is number to index, it will be key as a number integer, and value will be sorted set. As we want to return a minimum index, so we will use a sorted set instead of tree set, because if we use the tree set we have to iterate and get the first element and return. But for sorted set there is a method as first, and it will return the first element. So we are going to use the sorted set, and this is integer and integer, which is index to number. So let's take map of integer and sorted set of integer. It will be what? Number to index. Map integer comma integer, it is index to number. And we have to initialize it where? In our constructor, this, because when we get this request, that means it is initializing again. So number to index is equal to new hash map, and index to number is equal to new hash map. Okay, now for change, what I said is, first we will see if my number is there in this number to index. Okay, if number to index dot contains key number, if it is not there, then we will initialize. If it is not there, we will initialize. What we will do is number to index, wait, here it should be I capital, right? Index here also, dot put what, this number and new reset. Okay, anyway, why we are doing this is this is a, you can say the sorted set is an interface and their implementation is reset, similar as you can see map and hash map, right? So now we initialized with the empty tree set. Now what we will do is we will check if my index, what we did is now we initialize this and then we will check what is the number in for that index, what is the number. So if my index to number dot contains key as index, if it is there, and if that index to number dot get index, if it is equal to what number, then we will return from here, because it is the same, we don't have to again replace or make any change. If not int previous value, what I'll get this previous value, what, now we got 10 or previous value, what we will do, we will remove the index from that 10, then number to index dot get dot get what, this previous value dot remove this index. If we do this get, we will get that set, and from that set we will remove this index. Okay, as we are using the sorted set, we can use this remove and all. Now we removed, and now we, what we have to do is, okay, we will do outside that, we have to add, anyway we have to add what, number to index dot put that number comma, not like that, number to index dot get number dot add that index, and again what here, index to number dot, here we will use a put as index comma that number, as we have to just replace, here we have to add in the list, okay, sorry, in the set. So this is we will do in a change. Now for a find, what we will do, if my number to index dot contains key number, and also the site should be the site, as you know, we are initializing here, right, this thing, but it's not necessary every time there will be a number. Okay, so what we will check, otherwise it will return a exception, no such element found. So what we will do, number to index, what happened, number to index dot get okay, get number dot size should be greater than 0, that means at least 1. Then what we will return, we will return number to index dot get number of what, first, else we will return -1. So let's run. Okay, what it is not variable number, okay, here it should be number, right? And is there any other, here also we use the number. Okay, let's run again. Yeah, you can see accepted. Let's submit this. So here which we use the two hash maps. One is number to index and one is index to number. Why number to index? Because at multiple index same number can be there, but at one index there will be only one number. So we have to replace it. Thank you so much for watching this video. If you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated.